All right, we're going to do one more example here in 14.1. In June 2009, an onslaught of miserable weather in New England played havoc with people's plans and psyches. However, the dreary weather brought a quiet benefit to many city neighborhoods. Police reported that the weather was a key factor in reducing fatal and non-deadly shootings. For instance, it rained in Boston on 22 days in June when 15 shootings occurred. In 2008, the city saw rain on only 8 days and 38 shootings occurred. The table shows the number of rainy days and the number of shootings that occurred. Calculate the sample correlation coefficient between the number of rainy days and crime. So we want the R here. So we're going to go in and we want the correlation between rainy days, comma, and crime. So what have we got here? So we've got R equals negative 0.493. So, okay, negative means it's going down. It's not at 0 and it's not at -1. So, maybe there's something there, maybe not. Specify the competing hypothesis in order to determine whether the population coefficient between the number of rainy days and crime is negative. So we want to know if it's less than. So when we go to write our null and alternative here, we're talking about less than. Recall way back when that, because we don't have equality, we're going to make that our alternative. Less than 0, negative, which means that our row would be, greater than or equal to 0. Okay, and this is the claim that we're talking about here, that it's negative, all right? So that there is a negative relationship here, that, the rainy days are making crime go down. So calculate the value of the test statistic and the p-value. So our test statistic, we're going to need our n and our degrees of freedom. So our n, we're talking about 1, 2, 3, 4, 5. So our degrees of freedom is 5 minus 2. So our degrees of freedom is 3. So our test statistic here is equal to, so our R value over the square root of 1 minus our R value squared over 1 minus our R value squared, and then 5 minus 2. So when we type that into our calculator, 1 minus, and make sure you use a parenthesis for that negative 0.493. Otherwise, when you square it, it's not going to give you what you want. You should get, when you square that, 0.756951. I'm not going to round it. I'm just going to divide by 3, and then I'm not going to round it. I'm just going to square root it. And then I'm going to divide that by negative 0.493 by my answer, and I get my test t is equal to negative 0.98. And you could say that, or you could say 1, whatever you want for rounding. The less you round, the better it is. So that's our test statistic. Our p-value, all right, so in this case, our p-value is a left-tailed test. We've got a left-tailed test because of our alternate hypothesis, right? It's pointing to the left. So we're going to use 1 minus t. Right, and if you remember, the t-distribution is the reverse of the normal distribution, and so, when we're shading this way, the normal distribution, we're happy about that, but t-distribution, it's the opposite. So our t-distribution, we've got negative 0.98, and our degrees of freedom is 3. So when we get that back, we get a p-value of 0.1997. Okay, so we got that. At the 5% significance level, what is the conclusion? So our alpha is 0.05. Our p-value is greater than our alternative. So do not reject the null. So we're going to keep the null. So what that actually says, we're not rejecting, do not reject the null. And so we cannot say, we can conclude that the population, at 5% level, we cannot conclude that the population correlation is negative, right? We're saying it's greater than or equal to 0, so we cannot say whether dreary weather and crime are negatively correlated, all right? And then here's kind of all the, the work there for you again if you want to see. And then go ahead and give these 2 problems a try. Press play when you're ready to see the solution. And that concludes 14.1.